Alright guys, now that you have mastered gravimetric, solution, and gas stoich, we're going to work on limiting and excess reagents. So this is kind of like s'mores. If I gave you 6 marshmallows and 6 graham crackers, how many s'mores could you actually make? It would be 3, of course, because we need 2 graham crackers for every s'more, and you would have some extra marshmallows left over. So that's the same sort of thing in chemistry. So limiting would have been the graham crackers, and excess, we had more marshmallows left over, would be the excess. So the limiting reactant or reagent is the reagent that is completely consumed in the reaction, and the excess is left over at the end. So to determine the limiting reagent, you find the number of moles of each compound, so you'll be able to find the known of each reactant. Convert the number of moles of each compound to the number of moles of one product, so choose one and calculate the moles of product from both reagents. Whichever the smallest number is the limiting reagent. You continue the stoich problem with that reagent ignoring the excess. So let's give this a try. If 10 grams of copper is placed in a solution containing 30 grams of silver nitrate, which reagent will be the limiting reagent? So first step, as usual, is to write out the balanced chemical equation and write out everything we know below each reagent. Now, because we're talking about masses, we're going to need the molar mass of each compound. Alright, so now that we've written out our equation, everything we know, we need to figure out who will be used up first in the reaction. So the way I know that it's a limiting reagent problem is I can calculate moles of 2 compounds, all right? And I may be asked about the mass of a product being produced, or in this case, we're just asked which reagent will be the limiting reagent. So let's convert it to product. So let's say we're going to find the number of moles of silver from each compound. So starting with copper, we're going to do unit analysis, and we're going to stop at moles of silver. So that's right after our mole ratio, rather than going all the way. We could, no big deal, you'll still get the same answer, okay, but just a little bit more work. So 10 grams of copper times 1 mole of copper per 63.55 grams, so grams have canceled. We're at our mole ratio, so we have unknown, so 2 moles of silver all over 1 mole of copper. Moles of copper cancel, and we are left with 0.315 moles of silver would be produced if copper was the limiting reagent. Okay, so if we had lots of extra silver nitrate. Now let's try this with silver nitrate. So AgNO3. And so we are going to start with 30 grams times 1 mole of silver nitrate per 169.88 grams times 2 moles of silver per 2 moles of silver nitrate. We've had some unit cancellation here. We're left with moles of silver, which is excellent. We need to compare when we're talking about the same product here. So we get 0.177 moles of silver. Therefore, we are going to run out of AgNO3 before we run out of copper, because AgNO3 can only make 0.177 moles of silver, whereas copper can make almost double that. All right, so we would continue the problem if I was asked to solve for the mass of a product formed with AgNO3. All right, what mass of PbI2 is precipitated when 60 mils of 0.2 molar Ki is mixed with 85 mils of 0.141 molar PbNO3? So we need to write out our balanced chemical equation, and instead of using masses this time, we're using concentrations and volumes to find moles of our reactants. And I'm going to find moles of PbI2 precipitated. So let's start with our reaction here. All right, so you can see that we have enough information to calculate the number of moles of one reactant and the other reactant, and we're asked information about a product. So because there's two knowns, we know that this is a limiting reagent problem, and I do need to calculate the number of moles of product produced. Now, because I'm asked for the mass of PbI2, instead of stopping at the moles of PbI2, I'm going to go ahead and calculate the full mass of PbI2 using both reactants. So starting with Ki, we would have 0.0600 liters times 0.200 moles per 1 liter, cancels, times 2 moles of Ki underneath 1 mole of PbI2, and times the molar mass of PbI2, so 461.00 grams per 1 mole of PbI2, and that gives us 2.77 grams of PbI2 if Ki is the limiting reagent. So next step would be to see what you would get in terms of moles if lead nitrate was the limiting reagent. So PbNO3 2. So we started with 0.0850 liters, or 85 mils, times, we need liters on the bottom and we're working towards moles. Moles per liter is concentration, so 0.141 moles per 1 liter. Liters have canceled. We're at our mole ratio, so we'll have 1 mole of PbNO3, per 1 mole of PbI2, and our moles of PbNO3 cancel, and we multiply one more time by our molar mass of lead iodide. So we get rid of moles. The only unit left, again, is just grams of our unknown lead iodide. When we finish that calculation, we get 5.53 grams. So this says that lead nitrate is going to make more lead iodide than what Ki can really produce. So because Ki can only make 2.77 grams, and lead nitrate can make 5.53. So potassium nitrate, is our limiting reagent. All right, just a quick challenge question from our very first example to do with copper and silver nitrate. How much in grams of our excess reagent will be left over after the reaction is done? Now, I'm just going to write out what we knew about copper and silver nitrate. So for copper, it would produce 0.315 moles of silver if it was the limiting reagent, and silver nitrates made 0.177 moles of Ag. Now, to figure out how much would be left over, we want to find out how much extra silver it could have made. So, because copper was in excess, I'm going to find out how much excess. So, we say that the excess is equal to the larger number, so 0.315 moles minus 0.177 moles, and this is 0.138 moles. So this says that copper could have made 0.138 moles more had there been extra silver nitrate. Now I'm going to go backwards to our original reactants to find out how much copper that actually means. And we always talk about it in products and turn it back into reactants to make sure that we've taken care of our mole ratio. So because there's 2 moles of copper, 2 moles of silver nitrate for 1 copper, we want to make sure we've taken into account that mole ratio. So always work in terms of 1 product or reactant. Okay, so because we're using moles in silver only, that's how we can compare between the 2 compounds. So, going backwards, this was 0.138 moles extra Ag that couldn't be formed because we ran out due to silver nitrate. So 0.138 moles of Ag times 2 moles of Ag from our mole ratio per 1 mole of copper, my reactant. So moles of Ag cancel out. And I'm just going to multiply by its molar mass to get back to our grams. And this gives me 4.38 grams. That tells me out of my 10 grams that I started with, 4.38 grams of those will not react because we've ran out of our other reactant and the reaction stops. So to find how much is in excess, again, always talk about it in terms of one product and convert backwards into that original excess reagent.